Hi, I am Revathi. I am working as assistant professor in SNS College of Engineering. Today we will discuss the topic about IP version 4. Internet Protocol version 4 is the fourth version of the standard that routes internet traffic and other packet switched networks introduced in 1982 by the Internet Engineering Task Force. IP version 4 is the most widely used version of the protocol despite the limitation of its 32-bit address space. With slightly less than 4.3 billion available unique addresses, the available number of addresses quickly began to run out. What is an IP address? An Internet Protocol address is a unique identifier for a device connected to a network. The unique identifier makes it possible for devices to find and communicate with each other. Initially, the main types of devices that required an IP address included network devices such as computers, servers, routers, and printers. However, with the Internet of Things, the list includes cell phone, televisions, refrigerators, automobiles, light bulbs, anything else capable of receiving or exchanging information over a network. Understanding IP version 4 addressing. An IP version 4 address is a series of 4 8-bit binary numbers separated by a decimal point. Although you may use any numbering system to represent a unique 32-bit number, most commonly you see using IP addresses expressed in dotted decimal notation. For example, google.com dotted decimal notation 172.217.168.238. Early IP version 4 routing. Initially, the standard defined the first octet as a network identifier, but with only 256 unique values, the number of available networks quickly ran out. Several different changes made over the years have allowed for the extensions of IP version 4's life. First came the division of available addresses into 5 classes A, B, C, D and E. The class system defined which class A network belongs in based on its first octet. Class A network is first octet begins with 0. The first octet identifies the network. Class A supports 127 networks, each with 16 million hosts. Class B network's first octets begins with 10. The first and second octets identify the network. Class B supports 16,000 networks, each with 65,000 hosts. Class C network's first octet begins with 110. The first 3 octets identify the network. Class C supports 2 million networks, each with 254 hosts. Class D network first octet begins with 1110. Class D is reserved for multicast groups. Class E network first octet begins with 1111. Class E is reserved for future use. Students are going to discuss the IP version 4 case study.
Hello everyone. Now we are going to discuss about the challenges of managing and optimizing the network infrastructure, particularly regarding the IPv4 address. Alright, everyone, let's address the IPv4 extension issue. Sarah, what's the status on our available IPv4 addresses?
Three critical relatively low. We have allocated almost all our addresses under the remaining pool one last plan given our expanding network demands.
That concerning we can afford network distribution due to address shortage. Have we considered implementation networks address translations NAT to extend our IPv4 resources?
We have already implemented NAT in some areas, but is not a sustainable solution in the long term. It's add complexity and can cause performance issues.
What about transitioning to IPv6? I have here it offer a vast address space and better support for modern networking technology.
IPv6 adoption is inevitable, but it is requires a significant investment in infrastructure and training. Plus, it's not a seamless transition from IPv4. We will need to ensure the capability with the existing systems.
Agreed, but we can't delay any longer. Our network growth won't wait for us to catch up. We should start planning a phased migrations to IPv6.
We could begin by deploying dual stack systems that supports both IPv4 and IPv6. This could allow us to gradually transition without disrupting current operations.
2, 1.
How long would a phased migration take, and what are the associated costs?
It's hard to estimate precisely without thorough analysis, but it could take several months to years depending on the scope. As a cost, we will need to budget for hardware upgrades, software updates, and employee training.
It is a significant undertaking, but it is necessary for the future scalability and security of our network. Thank you.